Welcome to Sachin Study Tech. Today topic is Hamiltonian Cycle. So it is also one of the applications of backtracking. So you can use the backtracking approach. You can find out how many number of Hamiltonian cycles is existed for the given graph. So what is meant by Hamiltonian cycle or circuit in a graph G is a cycle that visit every vertex of G exactly once and return to the starting vertex. So here you can see this is also same for TSP, that is traveling salesperson problem. Here the traveling salesperson problem you can take the edge cost, but here you cannot take the edge cost. So that is the only difference. Here also you can use traveling salesperson problem, you can solve by using backtracking approach. So you can find out all possible solutions, then you can pick up the best one. Now here it is, the time complexity of Hamiltonian cycle is big of n factorial, space complexity is big of n. So what is meant by articulation point? Articulation, any graph consisting of any articulation point, then there is no exist Hamiltonian cycle. Now you can see here it is, for example, here the vertex 1, here vertex 2, here it is vertex 3, here vertex 4 is there, vertex 5 is there. Here you can see this is a graph. So this point is called as a articulation point. This point is called as a articulation point. That means if you can remove this vertex, then it is a disconnected graph. Any disconnected graph, there is no Hamiltonian cycle. So this is a articulation point. So these are two components are there, then you cannot find out the Hamiltonian cycle. So now we can discuss one example problem here. For example, this is a vertex 1 A and vertex B and vertex, here it is vertex C and vertex D. Here this is a graph. So this is a graph. So how many number of cycles is existed in this graph? How many number of Hamiltonian cycles are existed? Is there any articulation point in this graph? There is no articulation point. Then Hamiltonian cycles are existed. How many Hamiltonian cycles are existed? Now we can find out by using backtracking approach. So I am consider A is a initial vertex. For example, same graph you can take here the number of, for example, weights. Later you can see, here you can draw the state space tree, solution tree. Here it is. For example, I am starting vertex is A. So here you can see visiting unvisited vertices are B and C and D. These are the unvisited vertex. Is there any edge from A to B? A to B is edge is there. So you can expand this. Next, here A, B is our visited vertex, C is not a visited vertex, and D is also not a visited vertex. B, C, is there any link? Any edge is there? Yes, the edge is there. Then here it is C to D, is any edge is there? C to D, and D to A. So this is a one cycle here. That means here you can see this is a one cycle. You can see A to B and B to C and B to C and C to D and D to A. So and D to A. This is one cycle, that is A to B and B to C, C to D and D to A. This is one cycle. Now we have to find out another cycle. You can see how many cycles are existed in this graph. Likewise we have to find out. So now here it is D. Now you can see it is unvisited vertex are C. Is there any vertex, any edge D to C? D to C edge is there. Now we can check. Here it is A to B is there, and B to D is there, and D to C is there, and C to A. So there is a edge. So this is another solution, like A to B, B to D, and D to C, and C to A. This is another solution. Now we have to find out, is there any other Hamiltonian cycle is existed or not. Have to find out all possible solutions. Now we can see here it is. Here it is, A, C are visited, B are not visited, B vertex B, and D is not visited. Now we can see C to B, is there any edge? C to B edge is there. Now here it is unvisited vertex are only D, so B to D is also there. Now we can see A to C, C to B, and B to D, and D to A. So here you can see here it is A to C, and C to B, and B to D, and D to A. So that is cycle is existed, that is A to C, and C to B, and B to D, and D to A. Another cycle is also existed. Now we can check. Now you can see, is there any other cycle is existed, Hamiltonian cycle is existed or not. We can check the all possibility. Here it is, B is unvisited vertex. Now you can see A to C, C to D, D to B, B to A. So that is also a cycle. Here it is A to C, C to D, and D to B, D to A. Here it is A to C, D to B, and B to A. This is also another cycle. Like here you can see unvisited vertex are C and D. Here it is C and D. So here it is D to A to D is there, edge is there, D to C is edge is there. So C to unvisited vertex only B, C to B is edge is there. Now B to A. So this is another cycle, that is A to D and C, and C to B and B to A. Here A to D, D to C, and C to B and B to A. This is also another cycle. Now we can see here it is unvisited vertex is C, so A to D, here it is C and B, A to D, and D to B is edge is there, D to B is edge is there, and B to C. Now we can see A to D edge is there, and D to B, and B to C, and C to A. This is also another possibility. So these are the all Hamiltonian cycles are existed. 6 Hamiltonian cycles are existed. Here it is A to D, and D to B, and B to C, and C to A. 6 Hamiltonian cycles are existed in this graph. For example, you can eliminate any one of the edge, then you can find out how many number of Hamiltonian cycles are existed. Like either A to D you can remove, or B to C you can remove any one of the edge, then you can find out how many Hamiltonian cycles are existed in this graph. So for example, here the traveling salesperson problem also you can solve the same thing. Here it is, for example, here the weights you can take. Here A to B is 3, A to C is 2, C to D is for example 4, here it is 5, here it is A to D is for example 3. So you can see here also you can find out all possibility in a traveling salesperson problem. Then which of the path is the shortest path, then you can consider that is the optimal one. In traveling salesperson problem also you can solve by using backtracking. Thank you for watching this video.